Hey guys, what I wanted to do today was quickly review how to calculate a standard deviation for a list of numbers like we did in class the last few days. First of all, we'll be taking this problem from the textbook, which is Elementary Statistics by Triola, 11th edition, and we will be working the problem number 24, page 112. Now this is the first part of a two-part problem in the textbook. What I would do is just work out the first part, which is the first set of data in that problem. I'm also changing the instructions a bit. They ask us to do something different here, but I'm simply going to calculate the standard deviation using the shortcut formula. Okay, let's begin by writing down the shortcut formula, which is taken from the textbook. Now notice in the formula here that we have the sum of x squared minus the sum of x, the quantity square. The number one mistake in this problem is to confuse those two, and so they are completely different numbers. Let's review how we get each of those. Okay, now first thing we're going to need here then in our formula is the sum of x squared. That means that we're going to take each of our x values and we're going to square them. So 6.6 times 6.6, 43.56, and so on down the list. I urge you to go ahead and work through these and then check your answers. Now, after you do that, we're going to need to total each of those columns. And of course, the summation symbol means to add up an entire column. So let's take a look then at our final answers for that. Notice over here that we have added the first column, and that number, 71.5, is what we will use as the sum of x. The 513.27 is the number that we will use for the sum of x squared. Now we'll put those numbers into our formula. Okay, now the n number, of course, is the number of items in the list. That is 10. The sum of x squared is the answer at the bottom of our second column. That number was 513.27. Now from that, we have to subtract the sum of x. That's the answer to the first column, 71.5, and that number must be squared. On the bottom, we have n, which is 10, times 10 minus 1. Now, I call this the plug-in step, and I want you to write this on your paper and on your test. Okay, guys, I want to show you how to type this in now to your TI-30XS calculator. Now, first thing we're going to do is to get the square root function, which is the second square root key. And notice that since we're taking the square root of a fraction, we want to hit the fraction button and create the fraction. Now we can just go ahead and type in the numerator or the top of the fraction. That's going to be 10 times 513.27. We're going to subtract 71.5, and then we're going to square that. I can just use my squaring key for that. Let's move to the denominator now using the cursor key. And on the bottom we're going to have 10 and then times the quantity 10 minus 1. Now, of course, we can see that 10 minus 1 is 9. 10 times 9 is 90, so I could have done that much in my head and just written 90. But what I wanted to stress here was the fact that we want to make the calculator's display look exactly like what we've done in the plug-in step. If you do that, we're assured of getting the correct answer. So let's hit enter now and see that answer pop up. The answer that we get is 0.476678 and a few other decimal points. Okay, the answer that we got from our calculator was 0.476678322, and of course, since this is a square root value, we realize this is most likely an irrational number that goes forever and ever and ever, and so we're going to need to round this answer to a more meaningful amount. Now remember that our original data set contained numbers that were to tenths place, or 1 decimal place. Our textbook tells us that the correct way to round is 1 decimal place more than was included in the original data. Since the original data had 1 decimal place, we want to round our answer to 2 decimals, or hundredths place. So in our complete answer, go to the hundredths place digit. That would be the 7. Let's circle that, and then let's look 1 decimal place to the right, and we notice that the arrow is pointing to the 6. Now remember the rule of rounding. If the number with the arrow is 5 or more, we will round up. That means we will increase the hundredths digit by 1 and wipe out everything else. So the correctly rounded answer, notice that I'm using the symbol, the squiggly equal sign, which means that this answer has been rounded correctly at 0.48. That's the answer to our problem. This is the professor, and I'll see you soon.